Hello friends, today we are going to see what is a circular linked list. In our previous videos we have seen singly linked list, doubly linked list, and today we are going to see the circular linked list. So here is the circular linked list. A circular linked list is a linked list in which the last node holds the address of the head node. Okay, means the last node holds the address of the first node, right? So as you know, in a linked list a node holds the address of its next node. Okay, so here see, node for which the data is A, this node is allocated on memory location 100. Okay, this is the head node or this is the first node. So this node holds the address of the second node. So the second node is allocated on memory location 200. So this address 200 is stored in the address field of the first node. Means the first node holds the address of the second node, and likewise this second node holds the address of the third node holds the address of the fourth node. Okay, now this is the last node, but in a circular linked list there is no last node because the circular linked list never ends. As you can see here, the last node holds the address of the head node, means the first node. That is why this linked list is called as the circular linked list. So see, the first node is on memory location 100. So this 100 is stored in this node, the last node. That means node D points to node A, that is the head node. So this is the circular linked list, and in a circular linked list any node can be the starting point. See, as this is a circle, so you can see here, see, if you can see a circle, so in this circle any node can be the starting point. So similarly in this circular linked list any node can be the starting point. So it becomes easy now to trace the whole linked list starting from any node. Okay, as you can remember, for a singly linked list, see, for a singly linked list, if you want to trace the whole linked list and if you are at node C, I will say this node as C. Okay, I will give the names A, B, C and D, and last node points to null because that is the last node. So if you are at C, then you cannot trace the whole linked list now. You have to apply some different methods to trace the whole linked list. Okay, because this linked list ends here. This is a singly linked list. Okay, but in a circular linked list you are allowed to trace the whole linked list starting from any node. This is one of the advantages of circular linked list. And also the memory field is utilized because the memory field of the last node goes waste in a singly linked list because the next pointer is null for the last node. But for a circular linked list, even the next pointer of the last node is used for storing the address of the first node. So this memory field is used in a circular linked list, while in a singly linked list this memory field is null, so it is unused. Okay, now the node structure of circular linked list is similar to singly linked list. There is no difference. See, struct node, character, data. This can be any data type, integer, character, float, any data type, and struct node star next. So this is the next field. This field stores the address of the next nodes. So this is the structure. There is no need to change the structure for circular linked list. So now let's see the program for creating a circular linked list. This is the actual code which we use to create a circular linked list. This code is very much similar to the creation of a singly linked list code. If you have seen my video, that is code to create a single linked list, then you will understand this code perfect. But it's not a problem if you have not seen that code. I will explain this whole code here as well. Okay, so this is the structure for the node. So as you know, the structure of the node is this. See, struct node character data. So data is here and struct node star next. So the next pointer. Okay, this is the address of the next node. Now let's go to the main function. Okay, so see here, there are some variables declared I, N, then character, item. Okay, then struct node star, new node, p and head. These variables we are going to use them in the program. Okay, so in the program you will understand the functions of these variables, like what are the variables used for. Now let's go to the first statement, that is printf enter number of nodes. So we will take the number of nodes in variable n. So number of nodes, right? Now scanf %d at the address of n means user will enter the number of nodes and we will take it in n. Okay, now printf enter the 0th node. So if suppose user has entered number of nodes as 3, okay, so there are 3 nodes in this circular linked list, then we will number the nodes as 0, 1, 2. Okay, means see, suppose there are 3 nodes in the linked list, so just assume the nodes are A, B, C. Okay, so we will call the node A as 0th node, then first node and second node. These are the indices of those nodes. You can see them as index. So if there are 3 nodes, we will say it as 0, 1, 2. If there are 4 nodes, we will say them as 0, 1, 2 and 3. Okay, so assume there are 4 nodes. So that means if we assume they are A, B, C, D, then they will be 0, 1, 2 and 3. So these are the nodes, right? So now let's see the next statement, scanf %c at the address of item. So it takes the user input, that is the character which the user enters. So we take it in the variable item. So at first just assume that user has entered character A. Okay, so suppose user entered the character A. Now we have to prepare a node. So the preparation of the node is here. What do you mean by preparing a node? Means you have to allocate memory to that node. Okay, so this malloc function in this statement allocates memory to the node by measuring the size of that node. See, it first measures the size of that node and then it allocates the memory to that node. So here it is written size of new node, and this much size is allocated with this malloc. So the whole statement is new node is equal to struct node star. This means the typecasting. So whatever is the size allocated in the memory, it is typecasted as a pointer to that memory location. Okay, so this is the typecasting as a pointer. So the new node becomes a pointer which points to that memory location which is allocated. So see, I will create the node. Okay, the node is created. This is the data is A, then the next pointer. Okay, and this node, suppose it is allocated on memory location 100. So the pointer new node points to this memory location, means the name of the node will be new node, means new node pointer points to this node. You can say in our terms like new node points to the node. Okay, so this node is located on memory location 100. We are just assuming that. Actually no one knows on what memory location this node will be allocated memory. Okay, that is the decision of the compiler or the RAM in our computer. Okay, so we just imagine that this node is allocated on memory location 100. Okay, so now next statement, new node points data is equal to item. So the data is assigned to the data field of the new node, means to the data field this item is assigned, this item value is assigned to the data field. So here is the item value is assigned to the data field. Okay, that is I have written already here. Now new node points next is equal to null, so the next pointer becomes null here. Okay, see, this is the creation of the node. We have created the node with these 3 lines. Now you have understood, so we'll go ahead. Now head is equal to new node, means we make head pointer point to this node, because this is the 0th node, means this comes before all nodes, so we call it as the head node. Now, and also pointer P points to this node. Okay, pointer P points to this node. This pointer P is used to trace in the linked list. Okay, so at first all these 3 point to the same node. All these 3 pointers which we are using at first point to the same node. Afterwards they are assigned their work. Okay, now let's go to the for loop. See, for I is equal to 1, I is less than n, I plus plus. So the 0th node is over now. Now we will go to the first node. So I becomes 1 here, as you know, the first iteration I is 1. Now you will ask me why I have printed enter next node here, and here I have written 0th node. So this is because we always create the 0th node separately and individually, and after that all other nodes we create in a for loop. All the other next nodes we create in a for loop. So suppose there are 500 nodes, suppose n is equal to 500, then the 0th node is created separately and 1 to 499 nodes are created in this for loop. Okay, 1 to 499 nodes are created in this for loop. So the 0th node is separate and 1 to 499 in this for loop. In our case 0th node is separate and 1, 2, 3, these 3 nodes will be created in this for loop. So I have written here next nodes. You can also write like ith node. Okay, ith node, and then you can print the I giving the number to that node, right? So now scanf %c item. So item is entered by the user, that item is now B. So item is B now, right? Now again same thing, nothing different from here, same code here for creation of the node. So see, new node is equal to struct node star malloc size of new node. By this statement we create a node. We allocate memory to this node now. So suppose this memory is 200. Okay, that is allocated, right? Now the node is created. Now new node points data is equal to item. Item is B, so B is assigned to the data field. B is assigned. Now new node points next is equal to null. Okay, so see, this is the new node. Okay, I will clear this here. Now this pointer new node points to this node because of these statements. Now new node points to the latest node here that is created just now. Okay, so new node points to node B. Now the important thing is the linking. How do we link this node to this node? Means the next pointer of the 0th node should point to the next pointer of the first node, right? Now see, P points next is equal to new node. See, P points next is equal to new node. This is node P. Okay, this is node P. So the next pointer of this node means this next pointer should point to this node. So now this is not null. We made it point to new node. P points next is equal to new node. P points next is equal to new node. Means here address 200 will be stored. P points next is equal to new node. So this is how we link the 0th node to the first node. Okay. Now for the next for loop, again one more new node will be created. So we have to prepare for that next for loop, and that preparation is here. P is equal to P points next. P moves on to the next node here. Okay, P moves on to the next node. Still this node is not yet created. We are preparing for the creation of this node, the next node. Okay, we are still in the for loop for this node. We are still here. P moved here. Okay, now we are prepared for the next for iteration. We are prepared for the next for iteration. How we prepared? We prepared by moving P forward. P is moved forward. In the next iteration, now we will use this P for linking. Okay, so see now again for I equal to, I will become 2 now, right? So I becomes 2. So printf enter next node. What is the next node? C. User has entered C, so the item becomes C. Okay, now new node. So create new node. Create new node. New node is created, right? So new node points data is equal to item. So now item is C, so C is assigned to data. Okay, and new node points next is equal to null. So suppose that this node is allocated on memory location 300. So this is the new node created. New node allocated memory location. I will delete this because this is the new node now because of these statements. Okay, so this is the new node. Now the linking statement, P points next is equal to new node. P points next is equal to new node. Means the next pointer of P will not be null now. It will point to the new node. P points next is equal to new node. Okay, so this will hold the address of the next node, that is 300, right? And P will move to the next node. This is the preparation for the next for iteration. So now let's go to the next iteration of for loop. Okay, so now I will become 3. I becomes 3. So for this third node you have to create the node. So as here there is less space, I will just clean this and write it in some compact way. So this is the linked list. Okay, now let's start. So I is equal to 3. Printf enter next node. So next node is D. So user has entered D now. Here it is D. Okay, now let's create a new node. New node is equal to struct node star malloc size of new node. By this statement we create a new node. Okay, so create that node. So a new node is created. So see, item is assigned. Item is D now. This is D. So D is assigned to the data. So D is assigned to the data, and new node points next is equal to null, right? That is null now. So now this node is allocated memory location 400. Just assume that. So now this is the new node. This node is created. Okay, this is the new node. So I will delete this. So now the linking statement. So P points next is equal to new node. So node P points next is new node. Okay, so address 400 will be stored here, right? Now P is equal to P points next. So P jumps to the next node. So now in the next iteration, see here, I becomes 4. and 4 less than 4 is not true because n is 4. So we come out of this for loop. And when we come out of this for loop, there is a statement p points next is equal to head. So the next pointer of p, this is the next pointer, points to the head node, and this is the head node. Okay, this is the head node, right? So p points next is equal to head, and this statement makes it a circular linked list. This statement makes this singly linked list to a circular linked list. Okay, so this code is very similar to the singly linked list, only one change is this statement, right? If you add this statement after this for loop before the ending of the main function, then this linked list becomes a circular linked list. So this is how a circular linked list is created. In the next video, we will see a doubly circular linked list. This is a singly circular linked list, and now in the next video we will see a doubly circular linked list. And remember, this program I will post it on GitHub so that you can copy the program and use it for your purpose. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.